Hi there, I'm Michael Cohn from Advanced Tubular Technologies. In today's video, I'm going to show you how we can import STL data and then use it to measure the part and then align that data to the master nominal data. So STL data is a format that's output by a lot of handheld scanner types. So you can use a handheld scanner in order to scan the part and then import it into VTube as measured data, and then use that to find the center line of the part and the bend radii and then align it with the perfect model. That's what I want to cover with you today. So what I'm going to go ahead and do is I'm going to clear the project, and I'll show you, first of all, I'm using what is called a imported point cloud measuring device because we're going to have to measure point clouds. So what I'm going to do is connect to that virtual arm, and let's see here. We're going to go ahead and do this, turn the diameter cut plane off, going to measure setup and make sure that our point diameter, probe diameter is 0. And also for the ends, I want to make sure that our end scan flyer filters are off. All of these can be set up for default if you're not using an articulated arm, for example. So now what I'd like to do is go to step mode, and I'm going to import a perfect part or a nominal part. And we're going to go to auto build like this. Now, if this part's not already at the bender, then you could go ahead and send it out to the bender like this. But in this case, we've already got the part. The part has been measured, and we're going to import it as an STL file. So I'm going to go ahead and bring that in. And one of the things I'm going to do is, I think what I'll do is I'll reverse it. So this is bend 1. You don't have to, but that's just my preference at this point. I'm going to put the sharper angle at the beginning. So let's go ahead and do that. Let's reverse the XYZ data. I'm going to hit F2 to refresh, and there it is. So we got 1 through 5 there. Okay, now what I need to do is just go ahead and turn the master off for a moment. Go into Point Cloud Control, and we're going to go to the File tab, and we're going to import an STL file like this. So STL files can be quite dense point-wise, so it takes a while for all of the data to come in. What VTube does is it will fill the point cloud control with multiple buckets, I call them, of points. And each bucket will, by default, never have more than 10,000 points, because if we go display and active with, let's say, 30,000 points, the VTube might not like that, because the points themselves are quite intense on memory. So in this case, we can actually show them on the screen, but we don't want to go active with that many points. So right away, I'm going to go to Scan Setup, and I'm going to reduce the density like this. So let me turn numlock on, and let's retrim all the buckets so we can get rid of some of those points. We just don't need all those points. So now we have a reasonable number of points. Let me go to active here on these points, which means we'll be able to select them. And I'm going to reduce the scale size, just make it a little bit smaller. And then I'm going to hit F2 to refresh. There we go. That's better looking. And so now what I'm going to do is measure this part. This is like the part that's set in front of the measuring center. I can go ahead and turn this off. We can go to Measure Process, and we're going to multi-scan this tube. Now, the reason we're using multi-scan is because when we're measuring a point cloud, we cannot assume a stripe ordered like we would from a measuring center that gives us stripes of points, because these aren't stripes, they're just random points. In an STL file, it's very common to have one point at one end of the tube and the second point at the other end randomly placed all around the tube. So we cannot assume an order. And so the way to overcome the problem of how do you assume a vector, at least a best guess vector for a center line, is to use what's called multi-scan. In multi-scan, we take a series of stripes on one end of the straight and a series of stripes on the other end of the straight, thus implying a vector. So you're going to see that actually in operation as I measure through this. So I'm going to go ahead and zoom in here. It says it wants me to select an end. So I'm going to change from orbit mode by right-clicking on the mouse into select mode, and I'm going to put the mouse around the window around some of the points on the end of the tube. Now let me just flatten this up a bit. There we go. I can see some deformation or something here. I don't know what that is actually, but I don't want the deformation to impact the calculation of a cylinder. So I'm going to make sure that I don't calculate data using any of this deformation. So we're going to go ahead and acquire, and then we'll take a second stripe here and we'll acquire. There we go. Now let's orient for the next straight. All right, and let me change this to 45 so it goes a little faster. And then we're going to zoom in here, and I'm going to orbit around so this is more flat. And then let's orbit this way. Let's flatten this out a bit. There we go. Again, I'm going to try to skip this deformation at the end of the tube. Okay, let me just orbit around that. Looks good. And I'm going to grab some points on the end. Now we're going to finish and build. And at this point, if we want to, we can go ahead and perform an alignment and see if this part's any good. And I can tell you right now, looking at the lower left data, at 60 thou of deviation tolerance, this part is pretty good, not too bad, but it probably will need some adjustment. I can also see that maybe we need to adjust the bend radii a bit. So let me go ahead and turn off the align, the master, turn on the measured, and I'm going to do this. Let me just turn off the envelopes because we don't need them right now. And then I'm going to refresh the graphics again. Let me just take a look here. I'm going to orbit around a bit. Yeah, the first bend radius is a little bit off. No surprise there, especially on something this big. So we're going to go to measure process, measure the bend profile, change this to bend 1, and we're going to measure just the inside of the bend. We're going to collect some data on the inside, and you can see it fixed that problem. And let's take a look at bend 2. That looks good. Let's take a look at bend 1. Not too bad. So that looks plenty good to me. So we're going to go ahead and stop this measure, and we're going to go back to inspection data and perform another alignment. Let's see how well it aligns. Okay, so you can see that some of the pink tube, which is the measured aligned, is actually outside of the envelope, the tolerance envelope. Here it's okay, but here it's outside. Wherever you see pink coming out of an envelope like this, it means that that's where the part would rub the gauge if you were to put it into a gauge that's correct. Here's another place where it's coming out, for example. So there needs to be some adjustment made here. And so we no longer need the point cloud. So I'm just going to go ahead and turn the point cloud off completely. So see where it says on off here, display all off. And then I'm going to press F2 to refresh. Now that's out of the way at this point. It's really simple to turn it off. So let's say you have a connection to the bender. You'd go into bender setup, and then you would bring in your data from the bender like this. And the bender is going to answer with data in the blue column. That's the data that was used to bend this part, if you've bent the part. And then it's going to say, all right, you need to adjust this part by these values. And you can see it's looking like we need to reduce some of the lengths in the, here, and we have a little bit of adjustment in the rotation. The second rotation in here, 1 degree, is quite a bit. And then we need to do some overbend on that sharper bend angle. It's underbent. That's going to help a lot because it says you need to increase it by 2 degrees. The other two bends look really good. We don't qualify parts based on bend angles. We use the bend correction in order to adjust the bender. We qualify a part looking at the envelope, but I can tell you just from experience that 2 degrees is probably too much in a part like this, especially when you have a sharp bend angle. So we're going to go ahead and send the orange columns over to the bender if we had this bender here, which I don't, but I'm just simulating that. And then you bend the part, You measure it again with the handheld scanner, create the STL file. You go back into the point cloud control and you import the STL again, and then you measure it again and you compare it with the master part, which is the white part here, in order to find out if it's actually better than it was. Now let's say you don't have a connection to the bender. Just go into reports and just find the template that says bender corrections only, like this. And just take this data over to the bender, add it into the bender control, bend the next part, and you're golden. So that's how you can import step models and STL files and compare them to each other inside VTube Step and VTube-LASER. If you have any questions about what you've seen in this video, please feel free to email me at support@advancedtubular.com. Thanks for taking the time to watch this video. Have a great day.